If you use decision tree for regression, it is called regression tree. Otherwise, it is called decision tree for classification. Any questions on this?
Yeah, I have a question.
Yeah, sure. Yeah.
So, I mean, in Python, when we did the decision tree one, so we use that, let me see, the repeatability, right? That random state.
Yeah, because of the repeatability, I use the random state. Yeah.
So if we do that every time, we'll get the same data or different data?
Is it here?
No, not in this one.
Which Python notebook it is?
The decision tree regressor, that one. Yeah.
Mm-hmm.
So every time we'll get the same data or different data?
If you use the random state, you are going to get the same data again.
Okay.
In fact, we can try to run it and see. One second. Let it run through. Yeah. Let's run through all of this. So if you use random state equal to 1 dot shape, okay, it is 404 records. Let me give the head of this. Oh, this is numpy. Let me give first 5 records. Okay, these are your first 5 records regardless of whatever is the value. Okay, now let me run again, and this time we'll create another cell and run for xtrain of this one, just to show you these two are same. If you see 41415 e power minus 1 0 6.9, all these values are same. If you see the second time I ran also.
Okay.
Okay, regardless of how many times I run, if I run again the same values 1.14. Okay, random state will give you randomly, but for that random state, if you continuously run the same thing again and again, you still get the same answer. You're not going to get different answer. But let's say if I remove this, I run it, 2.730, 1.95, something else is coming. I run it again, 3.830, 1.8, something else. The first record is changing. I mean, it doesn't mean that only first record will change. All the records will change. Only that I am just showing you the first one so that it is easier to identify. Okay, let me call it again. Something else is coming as the first one. Something else. Again something else. So regardless of how many times you run, every time it is going to pick it randomly. So your results are also going to change accordingly, right? So today you say my accuracy is 95%. Tomorrow you go to your manager, it may go back to 90%. And that's not what you are interested in, right? You want to have a consistent accuracy. You cannot report your manager every day some new number. So for that, what you do, you set this random state. If you run now, if you remember the earlier values, the same values you got. As long as you remember your random state, you get the same set of data for training and test. The division will be exactly the same. Are you clear, Vijay, now?
Yes, Sandeep. And then I have another question.
Sure.
Under feature importance, You said that we can drop a feature,
Yes.
but and you mentioned, I mean, you showed us the percentages and you said that anything with a zero we can drop that.
Yes.
But is there a, I mean, I'm sorry, is there a guideline? So basically, if it is only 0%, only then we can drop it, right? Not like 0.09 or anything like that. Only when it's zero.
Okay. So you want 1 second. From sklearn.tree. One second. Let me run all of this again. Okay, mean squared error is also not there. Just 1 second. Let me import these things, then I'll answer your question. Okay, somehow not all these are imported. Okay. So your question is about the feature importance, right? So once we selected some depth, so I use that depth to classify again the final classifier. So I have many classifiers, each of which is having some variance or some bias or something. So what I tried to do is I tried to find out a depth at which variance and bias are traded off. I got a classifier. For that I did a training, and after training what I did is getting the feature importance. Now these are mostly like percentages. So for example, this is 58% of the time. This is giving me a better result than anything else. So first thing I should do is include the model, include the variables that are most important. Now, what is the second best? It is 25%. This one. Similarly, next one I think it is 7.6%. This one, and remaining things are also coming up after that. So the question is about, is there any guideline? So as far as I know, there is no guideline. But since this is giving some percentage values, you can have some guideline yourself. It's not something that anyone can give you the guideline. So for example, anything more than 1% should be taken. For example, what is anything more than 1%? This one is greater than 1%. This one is greater than 1%. This one, all of these are greater than 1%. But remaining things, the second one, third one, fourth one, fifth, sixth, seventh one, and 8, 9, 10, 10th, and 12th. These are saying I'm not even important more than 1%. Now, what do you do? So, in a way, I would say anything less than 1% is not at all useful. But does it mean 1.7% is useful? I don't know, basically. So, what you should do is you should try out with only these variables, whatever variables are more than 1%, and then try out if your SS residual, earlier my SS residual is around 15 something around 15. Now if my SS residual is reducing even lesser than 15%, or at least it is maintained around 15, then I can safely remove those. Otherwise, I should start introducing the others as well. Okay, 0 or something generally you don't have to worry about. But the question is, what about anything more than 0? Okay.
Okay, so basically we can drop the variable, drop these features and then
Try again.
run it again. And if
Yes.
the essence residual is lower than what we already have.
No, it may not be lower than that.
Okay.
That is a wrong statement.
Okay.
What it will be is SS residual will be closer to this. Let's say currently it is 15. It should not go beyond, let's say, 20 or 30. It should not suddenly go up. As long as it is nearby to this value, you are fine. Is that clear?
Yes.
It should not go, let's say, errors. If you see, we are nearby 14, I think, 14.7. That is depth equal to 4. Now, if your SS residual became, let's say, 17 or 18, that is also fine by dropping some variables. But beyond that, you're doing some mistake. Okay. Are you clear, Vijay?
Yes, Sandeep. I have no more questions.
Okay. So yeah, that's about regression tree. Any other questions?
No.
Okay. So the next topic is again within the family of trees itself. The topic is called random forest, or instead of calling it as random forest, or let me call it as random forest, no worries. So instead of creating one tree, the idea is to create multiple trees. Now, what is the advantage of creating multiple trees? That's what we want to understand today. So, what is this random forest? It is a technique to utilize the power of the crowd. What is this power of the crowd? So, what random forest says is the crowd is more knowledgeable than an individual. So, it is more like this. So, imagine that you are, in a some kind of a quiz program, and you are being asked some questions. You are being asked some questions. Now, whenever there is a question, it's only you that have to answer. But sometimes, if you do not know the answer, you can ask the crowd that is sitting in front of you. So, I think you have seen many of these kind of quiz programs. But the question is, how many times did you see the crowd answered wrong? I mean, crowd answered wrongly. I think it's not many times. whenever you ask the crowd who is sitting, or the audience who is sitting in front of you, and you asked what is the answer for this question, many of the times they answer mostly correct. And it's not that they all of them answer the same thing. So you'll be given it. So if you ask the crowd or the audience, if you ask the audience, so what they'll do is they will vote on different options. So each one will have few options to select from, maybe some A, B, C, D, one of them, and each one will choose one option. And what generally happens is, even though the question is very, very tough or very niche question, even then the crowd will be able to pull it off. They'll be able to answer it correctly as a whole, as a bunch. Maybe an individual in that crowd is going to answer wrongly, some individuals, but overall, once they vote on some different options, the option that crowd has picked is most likely the right answer. And it's not random that it's always happening the same way. It's not that always it's not just by sheer luck the crowd is going to always answer correctly. It is because of this particular interesting point that the crowd is always more knowledgeable than an individual. It is because each of the person has different area of expertise, and if you combine all of them together, all of their answers together, you're definitely going to get a right answer given a sufficiently larger number of crowd. And this is the exact thing that we want to use it in tree-based techniques, decision tree classifier or regressor, any of them. We want to utilize the same concept and try to apply the same thing on a tree-based machine learning models. Is it clear? What is the concept on random forest? How we are going to do, we'll do it. But is that example clear at least?
Can you scroll down a little bit?
Yes.
Okay.
So assume that each question is having some options. This is a multiple choice question. Each question has multiple choice. If this is not there, it is not, the voting is not going to work very well. So like A, B, C, D. You're being asked, the audience is being asked, you choose one of the options, either A, B, or C, or D. Is the question clear? Is the example clear?
Yes, Sandeep.
Yes.
Okay. Now we need to understand why this is going to happen. Why is that always crowd is more knowledgeable than an individual? How can it happen that even with a crowd or an audience who are who are not so knowledgeable individually, how can they be collectively knowledgeable? How is this possible? That is another question we need to answer, right? It's okay that yeah, the quiz program and all these are fine. Most of the times, yeah, it happens that the audience are going to give the right answer. But why is this happening? Why does it happen that always the crowd is intelligent? even though the respective individual who is present in that same audience or the same crowd, they are not so knowledgeable, they are not so experts. How can it happen? So for that, you need to understand the internals of the ensemble modeling. So let me give you one small example. So let's say so this entire region, whatever I have drawn, let's say this is your sample space, and let's say there is a person one who knows few subjects or few he has few interests in some of the areas, and let's say in this entire sample space of questions, this is your question sample space, whatever you want to answer, the entire questions are represented by this entire this kind of a area. So let's say there is a person one and he is knowledgeable in few areas, and obviously he is not at all knowledgeable in other areas. Let's say there are few areas like sports where he can answer the questions very easily, and let's say there are few areas like let's say um, let's say politics or international trade or something, he cannot even answer the question. So let me represent his the areas in which he is not able to answer properly using this circle. This is for person one. What it means is any questions within this area he will not be able to answer at all. Let's say I give for person two, there is another area where he is not able to answer the questions properly. And similarly, there is 3. And there are regions 4 and 5. You can have n number of areas where there are one or more persons or two or more persons who cannot, where you do not know, you do not have sufficient knowledge to answer the question. What it means is one can answer any questions outside of this circle. Similarly, 2 can answer any questions outside of this circle. Are you clear? Vijay and Abid, are you clear so far?
Yes, sir.
There may be overlaps also, because 2 and 6 cannot answer this region of questions efficiently. Both of them cannot answer this question. But 2 can answer any question outside of his own circle. Okay, let's say this point he can answer any question on any question here. So likewise, I'm just representing that same questions in a sample space. When I say sample space, it is a Cartesian plane, just in a graph. Any questions so far?
So anybody outside of their own individual circles, they can answer that question.
Yes, yes.
Okay.
This is their sphere of ignorance, more like that. Okay. This is or circle of their this is their circle of their ignorance. Okay. So each one is not an expert in all the areas. So for example, this circle represents, let's say, all the sports related not sports, sorry, all the politics related questions. This guy doesn't know about sports, let's say, and this guy doesn't know about physics. This guy doesn't know about chemistry, or this guy doesn't know about normal current affairs. Everyone has their own point of breakdown, right? At some point they cannot answer anything. So maybe some people's circle may be small because they know very well all the other subjects. Very few niche areas they do not know. The size of the circle may also vary. Some persons may have smaller circle, some other may be having moderate circle. Each one may have different circle, and this circle is not something that I can compute, but something that I can show it to you to analyze the things, basically. That's why I'm trying to use it. Okay. Are you guys clear so far?
Yes, sir.
Yeah, by the way, this is not my own example. This is one of the Stanford University's professor's examples, actually. And I liked it very much. That is the best best explanation I got for this problem. So anyway, so instead of taking these many points or these many persons circles, let me take only 3 circles, because it is much easier to analyze 3 circles, and we can anyway generalize the same thing to any number of circles, no problem. Okay. Now the question is, if these are the circles, or these are the area of ignorance, or a circle of ignorance for each of these persons, if we did a voting on these 3 persons about the question that is asked in the quiz program, what would happen? So there is a, let's say there is a point, there is a question here. I am representing a question by a point here. Okay, there is a question here, and I asked each of them to answer. Let's say the right answer for this question is, let's say this is an example. Example is about question 1, Q1. So what happens? Will one be able to answer the question properly? Yes or no? Hello? Are you guys there?
Yes, yeah, one can answer that question number 1. Sir.
Yeah, one can answer the question. What about 2? 2 can also answer.
Yes.
So let's say the right answer for this question is option A. Right answer is option A. So person 1, what will he answer? He'll answer option A. Person 2, he will also answer option A, because this point is outside of these circles. When this is outside of all these circles, all the persons will be able to answer properly. So this guy will also say option A itself. Now, what is your voting saying? I think in these TV programs, you'll see this kind of a bar chart. Option A, B, C, and D. Now, option A will be 100%, which is very rare, of course. But anyway, in this case, you are having 100%. Is that clear? So you are going into the right answer. at least for now. What happens if the question is here? This is another question, Q2. Let me write it as Q2. Yeah. What happens now? Example, this is one, or let me call it as question 2. Question 2, now the right answer is, let's say, option C. Option C. Now what will person 1 answer? What will person 1 answer for this question 2? He'll answer anything other than C because he doesn't know. Of course, by random chance he may answer C, but with the same random chance, he's going to answer wrong as well. Wrong answer as well. So something other than option C. He's not going to answer it correctly because his sphere of ignorance, this question is in his sphere of ignorance or circle of ignorance. He cannot answer that. He is ignorant of that question at all. What about person 2? Again, he's going to answer properly. He's going to say option C. Similarly, third person, same answer C, because he knows the answer. This question is not within this circle. Are you guys clear?
Yes, sir.
And what happens? C is going to get, out of 3 persons, 2 persons are answering properly. So what happens? You're still getting a larger proportion of persons answering this option C. How much it is? 66.7%. 2 by 3. 2 by 3 is 66.7.
66.6. Yes, sir.
Right? Yeah, whatever. 6, 7 or 7. If you round off, it will become 66.7. So what happened here is, whenever you have a set of questions and you have finite set of options for that, this works only when you have finite set of options and you keep an voting. What happens is, this voting is going to adjust your answer. This voting is going to give you most likely the right answer. There may be some cases where, the voting may give you wrong answer. What are those cases? Let's say there is another sample space or question space. In this case, earlier I wrote all those circles independently. They are not overlapped at all. What if they are overlapped? That is the simplest case, right? This is the simplest case I can get. This guy is knowing everything that other two guys do not know. But it may not happen the same way. What may happen is, all these circles may get overlapped like this. Let's say there is a fourth person also. Okay, all these things will be overlapped. Let me remove the fourth one so that it will be clean, at least. But this is how it's going to happen. These circles will be comparatively bigger than this kind of a smaller circle, and they will be overlapped. Now, what is the problem with this overlapping? How many times the crowd is going to say a wrong answer? In this case, the crowd is going to say wrong answer when more than one person, because there are only 3 persons, if there is more than one person who do not know a particular question, then the crowd is going to say the wrong answer. So for example, in this case, this is the area where the crowd can go wrong. Okay, but the only question I have is, yeah, the crowd can go wrong. So for example, there is a question here, let's say there is a question 3, both person 1 and person 2 are going to say wrong answer. Okay, both person 1 and person 2 are going to say wrong answer. Person 3 is going to say the right answer, but even though he is going to say the right answer, overall what happens? Let me give the new question, question 3. Let's say again, right answer is, let's say option D. So person 3, only person 3 can say the right answer. Only person 3 can say the right answer. Both person 1 and person 2, both of them are going to say wrong answer because it is in their circle of that ignorance, whatever it is called. I'm just calling it a circle of ignorance. You can call whatever you want, but this is the circle where he cannot answer the questions properly. So this question is in both the circles of 1 and 2. Because it is in both the circles, both person 1 and 2 are going to say the wrong answer, which means if you again go back to this bar chart where this is A, this is B, C and D, how many times D will be there? Sorry, D will be there only for 33% because only one person out of the 3 persons are going to say the right answer. But the other 2 persons may not be telling the same answer, right? The person 1 may be saying this one, person 2 may be saying this one. But assuming that the other 2 persons are going to say the same answer, let's say A. So what happens is this is going to be 66%. The other values are going to be 33%. So you can see there are only few cases where they are going to tell wrong. I mean, the crowd is going to tell the wrong answer. If you see the overall area that all these 3 circles covered, compared to that, the region in the red is going to be much lesser. Okay, the region in red is going to be much lesser compared to the area of the circles that you can see here, which means individually let's say the person 3, individually he is going to cover all this area. He is going to answer wrong. He is going to wrongly answer in this entire area individually. But collectively, what happened? The area where I can answer wrongly is going to reduce. Because of 3 persons, the area that is overlapped here is reduced very much. Are you guys clear? If you have sufficiently large number of people, this red region will keep on reducing. It's not that the crowd is always going to answer every question, but definitely it is smarter than 1 itself. If you see 1 itself, assuming that only 1 is going to answer all the questions, the area covered by 1 itself is very large compared to the crowd. Are you guys clear? What is this smartness of the crowd, how
Yes, sir.
Vijay, are you clear?
Yes, Sandeep.
Yeah, I think this is the best example that I have found over years of trying to understand this technique. So definitely I cannot explain better than this. This is like I said, this is also an example given by one Stanford professor. I forgot his name, but I think he's still teaching in Stanford. So any questions on this? Why is this? First you need to understand why is this working. Then we'll go back to the tree based models. How would we use random forest in tree based models? Okay, I hope this is clear for you. Anyway, keep thinking about this because it is easier for me to show in for 3 people. I just showed for 3 only. If I keep on adding the circles, so for example, the fourth person, if the fourth person comes in, then your area where you get a wrong answer will be decreased very much. If you keep on adding the circles, what happens? This area where you're going to answer wrongly, this red region, that is going to get reduced drastically. And at some point, what happens? Your accuracy will be very, very high. Okay. Hope this is clear. It's more like, this guy is a expert in medicine. Expert in medicine. But weak in mathematics. So he cannot answer anything about mathematics. So that's how generally it will happen, right? You cannot expect all these people should be experts in all the fields. Some fields they are ignorant, or say that they're not even, they're very, very weak. They cannot answer even a simple question. It might happen. But as a whole, if you look at the entire crowd, they are going to outperform him. That is the bigger idea there. Okay.
Basically, the more the number of circles we add, the less the error.
Yes, the less the region in red.
Okay.
Okay. It will keep on decreasing. The region in red, it will go on reducing. So finally, what happens is your accuracy or your accuracy of your answer is going to go up. Okay. Okay then. So let's take a break. We'll take a break until 7:25. We'll come back and understand the remaining pieces of random forest. Okay. The bigger idea, I think you got it. We still have to apply this to the decision tree. We'll do that. Okay then. We'll come back at 7:25. Are you guys back?
Yes, Sandeep.
Abid, are you back? Okay, continue. So I think you got the idea about how we get a better prediction or better answers by increasing the number of people in the crowd. So let's try to understand the same thing from the aspect of ensemble methods. So ensemble methods is these are the techniques. It's just a technique to combine multiple machine learning techniques into a final prediction or multiple. Actually, this is not how we should define this. Let me change it. This is a technique to combine multiple weak learners to get a strong learner. What is this weak learner? Weak learner is something who has a particular area of interest. So, for example, if you ask me a question on data science, probably I can answer, most probably. But if you ask me a question on, let's say, politics, I may not be able to answer. So I'm a weak learner. I'm a weak learner in that I have my area of expertise. Weak learner doesn't mean that he is weak in everything. He is weak in some areas and very strong in some other areas. That's what it means. Weak learner doesn't mean that he is weak in all the areas. In some certain subjects or certain areas, I'm very strong. But in certain other areas, I'm very weak. If you ask me data science, I can answer. If you ask me anything other than data science, maybe I may not be the right person. I may not be able to answer. So that is a weak learner. So, for example, if you go back to our discussion, yesterday's discussion on regression tree, you have. So this is a regression tree. So in this regression tree, you can see multiple variables. So first variable is crime in the town. Second area is residential area. How much is the proportion of residential area in that particular city? Next is non-retail business. You can see many different aspects of this housing price, right? So for you to identify the housing prices, you need to know some social aspects around the neighborhood, which is like crime rate, age of the other houses, all these kind of things. And you need to understand the economic aspects of this, economic aspects of the region where or the locality where you want to buy the house. For example, this is one of the economic aspects or financial aspects. Proportion of residential land in that region. What is the proportion of non-retail business? This is another kind of information that you need to know. So assume that these are all different persons. Crime is a different person. the residential area proportion is another person. Each one is a different person. Assume that. How do you know that? How do you know the final prediction? What you do is, first of all, you go to a lawyer or some person who is interested in the social aspects like crime. What is the petty crimes? How many petty crimes are happening there? How many serious crimes are happening in that region? All those kind of things. You need some person who knows about the criminal records of the people. Maybe some, you may want to go to some a lawyer or a police officer, someone who knows about the criminal history of the region. You want to go to that person and ask about that particular area of interest, whatever you are interested in. Then that gives you only one perspective, the perspective about the crime history of that locality. Then you go to another person who is who is an entrepreneur and who knows about the the financial activity that is happening in that locality. Okay, that is another way of looking things. So now what you do is you combine the knowledge of these two people and then predict the housing price in that locality. That is how you should do. If assuming that you don't have this data and you have only people, that's how you go and intuitively answer this question, right? Is that right or not? Next, you go to some environmental specialist. You ask about, what about the nitric oxide concentration? What about the how much is the amount of dust that you can expect in that region? All these kind of questions you'll ask to that to that person. Maybe the third person you go to, let's say some kind of a geologist, and ask about the quality of the soil on which this house is constructed. If the soil is too loose, maybe you'll see cracks in very few years. So you may not want to buy there. If the soil is very hard, then the property value will get increased. Are you guys clear how, in general, assuming that you don't have this data and you only have people to ask questions, how would you estimate the price of the house finally? Then you go to different big shots in that region and ask them what is their property value. Based on that, you can try to estimate your own value. So you go to different persons. Each person is going to give you a different perspective about the same data, same problem. The problem statement is same. I want to predict the housing price, but what I am doing, assuming that I don't have all this data, what I have to do for crimes, I have to go to one person who is a very well versed in the who has very good understanding about the criminal record of the city, maybe a police commissioner or someone. Okay, and then I have to go to some environmentalist to understand if the pollution is more. That's how I do, right? If I don't have this data at hand. Are you guys getting the intuition about this?
Little bit.
Mm-hmm. Are you having any questions?
No question. Just trying to understand.
Okay. So the thing is simple. So assuming that I do not have any any of this data, I have to go to different people if I want to understand, if I want to estimate my housing price based on the criminal record, let's say. First, I have to go to those people who knows crimes related information. I want to talk to them and understand if it is really worth buying at this place. Secondly, I'll go to some person who knows about the pollution. I'll ask them, okay, what is the nitric oxide concentration in this region? What is the amount of carbon dioxide or carbon monoxide that is present here? Is there any lead toxification here? Okay, all these questions you'll ask, right? How polluted is the water that you'll get here? All those questions you'll ask from that person. You'll gather those. So finally, what do you do? So to estimate the housing price, you combine the knowledge of all these people. Somehow, I don't know how to do that. Somehow you do it. Assuming that you don't know machine learning at all, what you do? You'll intuitively think, okay, there is a lot of pollution there, but it is offsetted by the number of industries around that region, which means there is a lot of demand for residential area in that residential land in that region. Because there is a lot of demand for residential area or residential properties, there is a kind of a increase in the demand. Because there is a demand increase, you can easily say that the housing price is more. Or it may be the other way also. There is a lot of crime there, and not much financial activity happening in that region, and pollution is less. But even though pollution is less, there is no financial activity, so the the price of the house will be less. You'll have an intuitive idea, maybe due to these reasons, it may not, the price may not increase more than 30K. Or the same way in reverse, because of these reasons, there is a lot of demand for this house, so the price may go up to 100K or 500K, whatever it is. Is that clear, Vijay? I'm not telling about the decision tree, I'm just telling about the idea how this random forest will come up.
Yeah, I get it.
Now, the same thing I have to simulate using random forest. How do you do it? So I need to have some experts in few areas. I need to have some expert in some other areas. Combine all those learnings and give you a better prediction. So to do that, what we do is we randomly, or we write it as a separate section, steps. To do this ensembling, what are the steps we need to follow to finally create a final random forest model? So first step is select randomly a few variables. So let's say I select randomly crime, let's say NOx, age, and tax. Let's say I selected these randomly, 4 of the variables. So with those 4 variables, what you do is build a tree. Build a decision tree. The same way that we did earlier. decision tree from the variables selected in step 1. So we already selected few variables out of all the available variables. From those variables, I built a decision tree. Keep on doing step 1 and 2 for n times, which implies we get n decision trees. We'll not get one tree, we'll get n different trees. But why are we doing this? We are doing this because each one will become a weak learner. Why will each one become weak learner? Because not all the variables are available to the first tree. Not all the variables are available to second tree. Likewise, all the, let's say I built 100 trees. All the 100 trees will not be experts in, will not be able to answer the questions in some areas, but they will be able to answer the questions in some other areas. The same way that I created this plot. Some areas the first tree is going to answer properly, but few areas it is not going to answer the few specialized areas the first tree is not going to answer properly. Same way with second tree, third tree, all those three things. Now what I do is we can use either bagging, I'll tell you what is this bagging or boosting to combine the individual predictions into a final prediction. I'll tell you what is this means. Now what I have is, I have multiple trees. Each tree is going to predict something. Now what I have to do is, I have to use, there are two techniques to finally do an ensemble model. The first technique is called bagging and very popular. In bagging, what you do is, it is similar to voting. Bagging is nothing but voting. What did I do in the quiz example? I just counted the number of times I said A, number of times the crowd said B, number of times crowd said C and D. I counted the number of times each answer is given. Similarly, in decision tree also, each decision tree is going to output one class, assuming that it is a classifier. Each decision tree is going to give you a particular answer. What you have to do in bagging is just do a majority voting. How many times you said yes, how many times you said no. Based on that, whichever is the majority class, predict that. That is called bagging. Boosting is a different technique. I'll tell you later. It's not something that you can understand immediately. But for now, assume that I have a way to combine all these predictions. See, there are hundreds of trees, right? And I don't have one tree. Each tree is going to give you some prediction. Now I have to somehow combine all these predictions into one prediction. One such technique is bagging. What bagging is doing? Just doing a majority voting. Whichever is winning, that is the final decision I'm going to take. Are you guys clear? What is bagging? Boosting I did not explain. Do not worry about it. Are you guys clear or not? Vijay, Abid, Vijay, are you clear?
Yes,
I
Sandeep.
did not hear you confidently saying yes.
Oh no, I understand it.
Okay.
Yeah, I understand, sir.
Okay. So that is what is bagging. In random forest, I have to have a way to combine all these predictions into one final prediction. So for that, I have two techniques. One is bagging, another is boosting. Bagging I explained. Boosting is something I will not explain today. But for now, let's only talk about bagging. So what is this bagging? It is a technique to combine multiple answers or multiple predictions into a single prediction. So I have n number of predictions because I have n trees. What I do is I combine all these predictions into one single prediction. So it reduces the variance in the model. What does it mean by variance in the model? What does it mean by variance in the model? So decision tree, if you build a decision tree by default, what happens? Each tree will be overfitting things, right? Each tree will be overfitting the data. If you built a full tree. Now, when you say you built a full tree, what happens? The depth of the tree is too much, too huge. It will be too huge. The depth will be too huge, maybe 10 levels, 100 levels. So you'll have 100 depth equal to 100 or 1000 or whatever it may be. And we already saw what happens when the depth is too much. So the depth of the decision tree, if it is too huge, what happens is the decision tree will be having very high complexity. Now what happens when the decision tree is having too high complexity? If the complexity of the model is too high, the variance of the model will be too high. What does it mean by variance of the model be too high? If you use a different training data set, you will get a completely different tree with the same model. Just by changing the training data set, you will get a different tree, and finally you'll get a different prediction. So every time you change the training data set, you'll get a different answer. Now what is the problem with it? Now let's go back and backtrack things, and it is the question that we just asked today morning. It is nothing but the train test split. We are randomly selecting the train data set and test data set, assuming that I do not give you the random state. Anytime I run this model, my answer will be completely different. If that is the case, let's see. This is the first model. Let me run again. Somehow it's not changing, right? Okay, don't worry about it. Let me give you random state equal to 2. I'm forcefully changing the random state, which means I'm going to get a different training data set. So I'm going to train the model on different data set. If I change the random state to from 2 to 3, I get a slightly different model. Now depth equal to 4 is not the minimum point. Depth equal to 5 is the minimum point. Now let me change the random state to 200. It is changing. The curve is changing. The errors are changing. Let me change it to 2000. It is completely changed. 20,000. So what this model is doing is, it came back to 4 again. The minimum point is 4. What is happening is minimum point is fluctuating around 4 and 5. That's how it is happening. Based on this, I can say that. But thing is, every time you have a different training data set. If I change the random state, obviously my training data set is changing. Based on the different training data set, I'm getting different errors. So that is what is the variance. What variance is saying is, you get a different model or different output every time you change your training data set. If the change is too much, you say that your tree is having high variance or your machine learning model is having high variance. If your change is too less, then you say the variance in the model is less. So always you should aim for a least variance model. Now random forest, the bagging, the technique called bagging is going to reduce your variance very much. Why is it going to reduce your variance? What you're going to take is, you're going to take the one that is occurring many times. What I'm doing is, in bagging, I'm simply taking the majority voting. If majority of the times I'm getting the same prediction, it means that even after changing the training data set, I'm going to most likely get the same answer. Are you guys clear what I'm telling? It's something that I need from your intuition. It's not something that I can. Are you guys clear or not?
Yes, Sandeep, I understand.
You understand why variance is less, right? What I'm doing is, I'm taking hundreds of trees. If for hundreds of trees I'm getting the same majority of the time I'm getting some answer, if I take that answer as my final model answer, then I'm simply reducing my variance. It won't change with the different training data set. So how is it working? For classification, take the majority voting. What about regression? For regression, take an average. Each model is going to give you some answer. Average value. Final prediction is going to be the average of all the trees. First tree is going to predict, let's say, your the housing price is 200k. Second tree is going to predict 150k. Third tree is going to say 175k. What is the final answer for your random forest? 200k plus 150k plus 175k. You combine all of them and say by 3. By 3 because I am taking an average of three values. If there are 100 trees, You take a average value of all the 100 values. Hope this is clear. Hope this is clear. Any further questions? Any questions on the random forest?
No.
So, okay. I kind of want you to repeat that one sentence. You said, okay, so we're taking hundreds of trees and
Yes.
say majority of the time we're getting some answer. And
Yes.
say we take that answer as our final model answer.
Yes.
Then the variance will be less, you're saying?
Yes.
Okay.
If many people are accepting the same answer, even if you change a little of your training data set, even then your answer, the final answer is going to be the same, because you're taking the majority, because hundreds of trees are coming up. It's not one tree I'm talking about. I'm talking about hundreds of trees. So even if you change the training data set a little, your answer is not going to vary too much. It might vary sometimes, but the changes in that is not going to be too much.
Okay, thank you.
Okay. Hope this intuition is clear. Why the variance is less.
Yes, Sandeep.
Okay. So that is about the random forest. Let me show you quickly the program or the Python code. It's going to be simple, not very complicated. Random forest. So let me run through each of them. The same data set I'm using this, it's not random forest classifier. In this case, I'm showing you random forest regressor. Both are same, except that in regressor you are going to get a continuous value. So each tree is going to predict some continuous value. You are going to average out all of those continuous values and then give a final answer. In random forest classifier, it's going to be the number of times, the majority voting actually. Okay, same thing, not very different. So I'm loading the Boston data set and getting the X and Y variables and also the feature names. The same thing, we already did all these things. Now I'm going to split the data into train, test and validation data sets. Train data set, test data set. First I have to separate, and from train data set I am separating the train data set into train and validation. So finally I get train, validation, test data sets. If I do it twice, I am going to get those things. Now, what I'm doing is I'm using this random forest regressor, and in this I'm calling n estimators. N estimators means number of trees. Estimator means one classifier or one regressor. So how many such regressors or classifiers I have to develop? 100. So 100 trees I am going to create. N jobs is nothing but the number amount of parallelism. Do not worry about this one. You can always use -1. Do not worry about this. Okay, this is a simple technique to speed up the things. And max features. At a time, how many features or how many variables I have to select at a time? I am saying square root. So how many variables I have? Actually, x train dot shape. How many x variables I have? 13. So what I'm saying is, at a time, I take square root of 13 variables. At a time, I'm going to take square root of 13 variables and I'm going to create one tree. And such trees, I'm going to create 100 such trees. Every tree is going to have square root of 13, which means 3.6. It is going to round up this to 4. So at a time, I'm going to take 4 variables and build a tree. And such trees I am going to develop 100 such trees. Okay, and each tree is going to have some min leaves. If you remember the discussion on decision tree, you'll remember what is this min leaves, min sample leaves. Number of samples, minimum number of samples that are to be present in the leaf node. I'm passing that as a hyperparameter to this method. Then I'm fitting the train data set and X-train and Y-train data set, creating a model and doing a prediction. And then finally getting a mean squared error between validation data set Y values and the predicted values from the X variables. What is the difference? Mean squared error between the validation data set Y values and the predicted values. Are you guys clear? The same kind of function I have developed earlier. There is no difference. Except that here I am using random forest regressor and giving some additional parameters, some different parameters. Are you guys clear?
Yes, Sandeep.
You can run as many estimators as you want. You can use 100,000, any number of trees. Only thing is your machine should be capable of processing that. Your machine should be fast enough, right? That is the only thing. Otherwise, as many as you want, you can create. Now, what I'm doing for every min leaf, I have to tune this parameter, right? Min leaves. So for every value for this min leaves, I have to run this random forest regressor and find out the error. So what it is doing, for number of leaves equal to 10, min leaves equal to 10. First it will develop 100 trees. For all those trees, it will try to predict this for the validation data set. It is going to get, for each of the 100 trees, it's going to get some predictions. It's going to average them, average all of those predictions. Then you'll get some predictions. Then for that final prediction, this prediction is nothing but average of all the 100 trees. For that final prediction, it is going to get me the mean squared error. Now, how many times I am going to run this? From minimum number of leaves 10 to 50. I am not running from 1 because it is useless. Minimum leaves equal to 1, 2, 3, all these are useless. At least 10 samples in the leaf should be there. If it is less than that, it is very bad model. That's why I am saying from minimum number of leaves 10 to 50, I am running this random forest regressor. Every time I'm going to get a mean squared error, I'm getting all of them in a simple list, Python list. So if I print this, you can see it ran for quite some time. If I print this, you can see all the errors. Instead of printing them, you can put it in a matplotlib, and you can see it is keeping on increasing. As and when the number of leaves are increasing, the error is increasing. What is the minimum point? 10. Yes or no? You always have to see the minimum point from this graph. Minimum point is, if you have 10 leaves, it is working considerably well. Are you guys clear? What is the minimum error? 20, 21. 21 is your minimum error from your random forest regressor. Are you clear?
Yes.
Yes.
Now the thing is, if you remove the random state and run it again, I'm not showing it again. I'm not showing it now. You try it and tell me if there is any difference in this graph. There will be some difference. Obviously, there will be some difference. but it won't be too much. That's what my intuition or my theory is saying. But what I would like you to answer is remove this random state, or instead of removing, you can try out different random states and tell me if there is considerable change in this graph. Is this graph changing too much? If it is changing slightly, that I am fine. My question is it changing too much? Is that clear? So I'll tell about the grid search tomorrow. But in the meantime, you try to answer this question. Try to change this random state for different values. Tell me if this variance is much or not. Or maybe I can try it for now. Random state equal 100. From 1 I changed to 200. Okay. It will take a few minutes. You can see why it is slow. Because the number of estimators for every 100, you have to develop 100 trees. And for every tree, I am changing these values. What are these values? I am selecting different values of minimum leaves. So these are 40 different values of min leaves I am trying. And I'm running 100 trees. I'm creating 100 trees, 100 such trees. 100 into 40. It is going to create 4,000 decision trees. That's why it is slow. Is it changing? Not much. Almost the same. Are you guys clear what is variance? Earlier I showed what is variance. The error is changing too much. Every time it is giving some different line. This time almost the same. It is still going to change. It's not that variance is 0, but variance is minimum. Are you guys clear?
Yes, Sandeep.
Maybe for 1,000 also I can try out again. One more time. One last time. So your homework is still intact. You can still try out many different values for this random state and try to run this code again. Try to see if this plot is changing too much or not. In fact, this is the best way I can tell you that variance is not going to change. I mean, variance is less. Okay. Curve is almost the same. There will be some differences. Obviously, there will be some differences, but almost same. Okay. That is your homework. Just try to run through with different random states. Take a screenshot of each of them. Random state equal to 1, random state equal to 10, 100, different values. You take a screenshot and send it to me over mail. And finally give me a final statement saying, is the variance too much or less? That is the answer I am expecting actually. Okay. How much, I mean, is the variance too much or not? You may not give me the variance value itself. Just give me saying variance is low, variance is high. For telling that, maybe start with estimators equal to 1. This also you change. For estimator equal to 1, is the variance too much? Or estimation equal to 10? How much is, I mean, is the variance moderate or maximum or minimum? How much it is for variance estimators equal to 10? Try out these values. Tell me the answers. I mean, just send me a mail about your findings. Is this clear?
So you want us to change the numbers for the estimators, not for the randoms?
No, both.
Okay.
So for example, for number of estimators equal to 1, let me show you. Random state equal to 1, number of estimators equal to 1. What happens now? Okay, let it run. Completed. Okay, this is your errors. Take a screenshot. Now random state equal to 10 for one estimator, which means one tree. How are the errors changing for different random states? Okay, it is a combination of both. Is the previous graph and this graph completely different or not? Yes or no?
Yes.
So this means at when estimator number of estimator equal to 1 for different random states, the variance is more. What I want to try out is try out different number of estimators from low to high, maybe 1, 10, 100 for different number of estimators. If the random state is changing, what is the variance in the data, variance in the errors? Are you clear or still confused?
I got it, something.
Okay, thank you. Hope this is clear. Send me the mail by tomorrow before the class. Okay, that will give you an intuition about what is this variance and how variance changes with the number of estimators. Okay, that's all I have. Sorry for killing your 15 minutes of time, but I hope this is a better spend of time. Okay, always you get a better knowledge on this subject only by experimentation. The way I told, changing the estimators, changing the random state, you'll get only the better intuition only by experimenting different options that you have, which I cannot teach in class, but I can help you understand, help you uh, try out the things. That is all I can do. I cannot try out all the different options. There are hundreds of options. Hope this is clear. So we'll catch up tomorrow again. Bye.
Bye.